Welcome to Season 7 of the Prosthetics and Orthotics podcast. This is where we chat with experts in the field, patients who use these devices, physical therapists, and the vendors who make it all happen. Our goal? To share stories, tips, and insights that ultimately help our patients get the best possible outcomes. Tune in and join the conversation. We are thrilled you are here and hope it is the highlight of your day.
Hey everyone, my name is Joris Peels, and this is another edition of the Prosthetics and Orthotics podcast with Brent Wright. How you doing, Brent?
Hey, Joris. I'm doing well, man. Spring has sprung here in North Carolina, so I'm looking forward to some warmer weather. How things out your way?
Super good. It's really nice here, and everything's going really, really well. So really, happy with everything. So, we have a sponsor, right, for this show, and that's Advanced 3D, I believe. And they're a contract manufacturer, design service for prosthetics, orthotics. Do you know anything more about them, Brent?
Well, funny you should ask, Joris. Advanced 3D, I'm a part of it, along with Tyler and Paul. We are a contract manufacturer, but I would say our wheelhouse is helping bring some of the products to market, or say something that's technical or technically challenging for a patient. That's something where we can definitely use our expertise and design something digitally and then 3D print it for you. And then the other thing that we can do is come alongside you and wherever you are on your digital journey. We talk about scanning, design, and fabrication, and we can help you with that as well.
Okay, super cool. So if you want to give a shout out to Advanced 3D or check them out, do so. So Brent, who do we have on the podcast today?
Well, today we have Sean McKale. He's the Director of Clinical Education and Customer Support for Becker Orthopedic. And Sean and I have known each other for a long time. And what's interesting about Sean is that he has chosen to specialize in the orthotic side of not only manufacturing, but as an orthotist, creating clinically relevant solutions for patients. And, Sean and I have a love for things that kind of dive into the weeds and get technical. And he gets way more technical than I do, especially on the orthotic side of things. But I think we can both agree, and this may upset some of our audience, but orthotics, or being an orthotist and doing orthotic devices, is much more difficult than making a prosthesis.
Oh, wow. You managed to alienate everyone here.
Except Sean.
Yeah, except for Sean. Half of our people have just dropped off and will never listen to us again. But Sean is super happy. Yeah.
Well, I always say, people come to the field because prosthetics are sexy, people, real visual, and everyone sees and is exciting. But orthotics are challenging and interesting, and that's really what I think keeps some of the clinicians more engaged when they get into the field too. So a lot of students, especially now that you go to school and become both CPO and so you're studying both orthotics and prosthetics, you get to discover all this challenges that orthotics provide you. So I love it, and they are absolutely, I think, more challenging than prosthetics.
Okay. So how did you yourself get involved in the field, Sean?
Sure. Thanks, George. First of all, guys, thanks again for the invite into the podcast and sharing some of my story and what we're doing at Becker today. I'm excited about that. But I started out as an athletic trainer at Purdue University. I thought I was going to become a physical therapist when I graduated from school. And the reason I chose Purdue was because most of the staff was athletic trainers and physical therapists. And I was getting done there and sitting down with my mentor and kind of saying, I think I want to go make furniture, do something more with my hands. And he said, well, what do you like about athletic training? And, I liked when we made these felt pads to go inside guys' shoes and kind of test out if orthotics would work. And then we'd take foam box impressions and mail those off. Or we made wraps around their arms and put this paste over it that they used in the veterinary college to euthanize horses, but we used to make splints out of. And I didn't realize it was a profession that I was describing that existed out there. So he hooked me up with the guy who was kind of our DonJoy rep, who in turn hooked me up with someone who was down at the VA in Indianapolis. And I went down there and I shadowed for a day, and it was just, I thought, amazing. He was mostly fitting diabetic shoes all day, which, for people in the field would be chuckling at that, calling that amazing. But I was enthralled by it. And he suggested to me, because I was from the Metro Detroit area, that I try to get a job with a company called Wright & Philippus, because they had helped pay for some of his classmates to go to school. And that's what I did. And I was fortunate to get that opportunity, returned to Northwestern as an orthotic student. That's back when it was still a post-baccalaureate certificate program. So I never returned and did the prosthetic aspect of it, but I was fully engaged and dove into the orthotic portion. The residency program at the time was a really great program where we got to travel between the different clinics of Metro Detroit and really experience, those different specialty clinics and develop who you were as a clinician too. So we went to diabetic wound clinics, we went to spina bifida clinics, post-polio clinics, spinal cord injury. Got to see just a real full gamut of what the orthotic experience was: scoliosis, acute care, all of those different things. And then at the end of my residency, I got to kind of figure out where I was going to fit best, and also where they needed me best too. So I got to lead an office at the Rehab Institute of Michigan in Detroit. And that was a really cool experience because I got to develop more as a neuro orthotist, if you would. So seeing those acute care rehab patients, spinal cord injury patients, post-stroke, TBI type of thing that was, are challenging, but I really love being there kind of at that initial phase of recovery and being part of the team. I also got to be part of one of the first in the country. It was the first dedicated clinic to Charcot-Marie Tooth. And been an advisory board member for years with the Charcot-Marie Tooth Association. Eventually left Detroit, took an opportunity to open a practice for Midwest Orthotics. After meeting Bernie Veldman, he wanted to open a practice up in Chicago. Moved up there. I was there for about 8 years. And that was a great experience. I loved traveling around to schools and therapy centers and our mobile labs. Still really focused on pediatrics and adult neuromuscular. And then later took a position at the University of Michigan running their acute care team. So we dealt with all the trauma cases, putting halos on patients. We had scanned people after spinal surgeries, or if you came into the hospital with a broken back and they weren't going to do surgery, but they were going to fit you with a custom back brace. That was our role. And we fit those within a 24-hour period in most cases, where we would scan the patients, fabricate the custom TLSO in-house, and then deliver that so the patient could be discharged. So I really enjoyed that role as well. One of the things that I got really excited about working with the rehab patients was using the Becker Geos, the gait evaluation orthosis, and the triple action joints. That joint technology and the change in it really got me excited about things we could do for patients in terms of optimizing their gait. And I got a little too excited that I started talking with Becker, and they decided I needed to start coming and telling some other people about that too. So that's kind of how I talked my way into this role, if you will. And now what I do is I help consult on the jobs that come in through our central fab, questions customers have through manufacturing on componentry selection, as well as educating at a lot of our national events. So kind of a mixed role between, R&D in some cases. Sometimes it's also just our regular CFAB production. I'm really enjoying myself and the progress my career has made so far.
And the thing is, so most people do both, right? Especially now, right? Almost everyone does both. And now you're looking back where you're like, oh, wow, I actually would have been valuable for me to go back, do that extra time and do that prosthetics bit as well? Or do you say like, oh yeah, there is a case to be made to doing like only orthotics and being like 100% Mr. and Mrs. Orthotics?
Well, I think there's value in learning it all. And I've certainly been around enough prosthetists, managed prosthetists, seen a lot and learned a lot from our prosthetic colleagues as well too. So I haven't been shut off to that, even though I didn't necessarily do the formal education on it. I think, that there is a huge scope that we have as clinicians, and the design and the 3D printing thing is such a small part of even the need of what our patients have too, right? And it's a great tool in the toolbox, but we have so much breadth of what we do from the moment we evaluate and ultimately the moment we deliver something and how we follow up with that and the care we provide as clinicians. And I love that, but being able to put yourself into a more specialized area is also something that's really kind of unique about this field too. Whether you could be someone who just wants to do cranial remolding orthoses all day and have a busy practice, and that's all you do. If I never really had the opportunity to do a lot of scoliosis, but if I had to redo my orthotic career, that might be an area where I'd focus more of. I really am passionate about the lower extremity, and that's what my major focus is at the moment is outcomes we have and the work we're doing with lower extremity orthotics. So even within, as an orthotist, I think you specialize and you do the thing that you do. It's hard to be great at everything. It's hard to know everything about everything, right? So it's great that people have this opportunity to specialize and have colleagues around them that they can defer to or ask questions of. So, I think there's benefit and there's disadvantage also to being too general. So.
Okay. And if I was like either like a orthotist prosthetist, but like more towards a prosthetist, and I want to learn more about I want to learn how to make a better orthoses and stuff like that. Or if I was just a student starting out, what would how would you say I should get started? Well, how would you advise me to know more, to learn more, and to really become more expert at this area?
Yeah, I mean, I think school was great, and I really appreciate the education I had at Northwestern. But leaning into your mentors and really understanding how they're processing the information. What did you see during that patient encounter? Understanding the biomechanics. Take your questions home with you. Try to understand deeper. Read more. I definitely feel early in my career I was able to advance and move forward in ways my colleagues weren't, especially with things like adapting to using stance control early on. Part of the reason I was put in the position that I was with the company at the time was because my willingness to adopt and use some of the newer tech that was out there. But that took understanding. I really understood what the limitations of that were, what the right clinical presentation was that met that device, and what it could or could not do too. You can't just put every spinal cord injury patient in the stance control KFO. You had to understand what the restrictions of that and what was going to be the right implementation of that as well too. So I think just really trying to lean into all the learning opportunities, ask all the questions, and have an opinion. Have an opinion about what you just saw and what you would have done maybe differently. Even when I deliver something to a patient now, I still think about, well, how could I have made that better? What could I have done to improve that? Made it a little faster the next time? How could I have communicated with the lab that I'm working with to get it back so it may have just slapped on a little faster and not required so much time through the delivery appointment. So I could have focused more on the tuning things or the adjustments that the device has, rather than spending all the time on trimming the trim line back or adding an extra pad or something that maybe if I thought about a little bit more in advance during our evaluation would have gone faster than in my delivery appointment too. I think constant improvement is really important for all professionals. It all starts at the input of what we provide to our fabrication partners, whether we're fabricating in-house and using a technician who's shoulder to shoulder to you, or you're sending it to a CFAB like us at Becker, and you really if you have a question on that order form and you don't know why are they asking me toe in and toe out? And I don't know how to really answer that or how they're measuring that. Make a phone call. Really, really get good understanding of those forms you're filling out. Complete the forms that you're filling out. Nothing is harder for us when there's a missing question on that order form, or there's contradictory information sometimes too. But we can't proceed into production unless we have good clarification on what we're about to manufacture for you as a customer too. So those relationships, and it all starts with communication, really important for you.
So talk to me about this fitting for the device. Like,
Sure.
what are some steps that I think everybody knows this generally, I think, but I think that we would benefit a little bit more knowing, like, are there really specific steps you would say, like, that are really like key to success, or things that people should be doing on top of what everyone else does to really make sure that patient gets the best device, it's the right alignment, all that kind of stuff?
Well, I'm a believer that the foot really needs to be in good joint congruency to create power to, help patient with propulsion, and ultimately adoption of their orthotic. And if you have poor alignment, how are you improving that alignment? So if you've built or designed the orthotic in a way that we've got good postural control, first you have to assess that. Did you actually gain that good postural control then at that delivery appointment or not? If a patient has complaint of pressure on their navicular bone, for example, what do you do about that? Do you just heat out the orthosis or bump it out more? Or do you need to add a medial forefoot post or an ST pad modification or padding along the supramalleolar area and what we call a sablage modification? You have to address the individual's positioning and look at it critically as you're delivering it to say, did you meet the goal of what you expected to do with the product? Maybe you cut the trim line too low. Maybe you did something that sacrificed the result to fit it inside of a shoe. And I think that criticality of what you're doing and how you're doing and that you met your goal at the delivery appointment is just as important as making the goal to begin with, too. To me, it's really about assessing that you accomplished what you set out to achieve. And first thing with lower extremity orthotics, especially, did I get the alignment? Do I have the postural control that I need throughout the gait cycle and while the user is using it? And that ends up being comfort for the person. So do they feel comfortable in it? And that's what they're expressing to you. I feel this bony pressure, but that bony pressure to you should be a light bulb of, I missed out on an opportunity to control this limb in a way I meant to do so. So it's not always a direct route to what the fix will be, but you have to be able to interpret the information your patient is giving you to making sure you're getting the result that's needed.
Sean, can you dive into that a little bit more on the? I know you kind of glossed right over that, but I think it's super important on the alignment side of things and some of the bony stuff that's going on. If a patient is, say, getting a pressure on the navicular and what have you, the first answer to me, at least this is what my mentor said, is not blow it out and throw a pad in it. It is, what can you do to support it to keep that bone from hitting?
Yeah, well, exactly. I mean, I think you do need to look and see, is the relief in the right spot? Did we relieve it sufficiently enough? I don't think you need to ignore that entirely necessarily. Excuse me. But beyond that, I do think you need to be critical of, how was I anticipating correcting this foot alignment to the joint congruency that I evaluated or anticipated? And why am I losing out on that? So was it an issue of a trim line? Was it a rigidity of the material? How can I improve that? Do I need more medial longitudinal arch padding or an ST push? Or do I need more of a forefoot intrinsic post? The answer isn't necessarily always going to be the same for that. You have to go back and reassess the result that you have. And I've been there. I expected more of a calcaneal grasp than I accomplished. So I have a recovery for that. Now I'm going to go take some Trilam and skive it in a way that I know will help and work for me in that regard. So I think you have to address it individually, but that's one of the great things I think that we can do as this profession is we're not necessarily stuck where we're at. We can fix it and change it, but we need to look and be critical of that result as we have it too. Otherwise, there's no recovering, And I being in a CFAB like this, we see all different things that occur and things that get sent back sometimes, and it's like, well, they've trimmed the edges all the way off of the orthotic, and then they're wondering, well, why is the person running into the metal ankle joint? And it's like, well, you sent me a picture of the person's foot too, and it's completely rotated to the side, and you've removed any control mechanism you had for that posture. So I think that's very fundamental to what we're thinking about when we're designing or how we're planning to control and use our orthotic devices on our patients' feet.
What I'm very interested in as well is are there any kind of quality control routines or steps? You said this bony, kind of feeling pain with the patient, obvious, right? But are there other things that you recommend people do? Because to me, it's usually would seem to me that with a prosthetic, the mistakes would be very obvious very early on, right? For the professional and also the patient. But with an orthotic, I could imagine you could make a mistake that someone notices when their back gives out 6 months later. You know what I mean? Are there any kind of steps you would super recommend for people to do to really reduce problems and stuff like that?
Well, I think first to defend the prosthetic colleagues a little too. That people change. There's a lot of dynamics in their presentations. They're not the same they are the day you delivered the device. They have volume fluctuations, activity levels, muscle strength. All of these things have an impact then on the outcome of that fit of that socket. And to the orthotic too, right? Like the orthotic won't really change unless we do something to it. And that's something I help to share with my patients. Like, I want to know if this thing feels great today, but a week from now, if you're finding you're not able to wear this because, standing on it for 6 hours is bothering you, and that's not helping you to accomplish your goals, I want you to call me. I want you to come back and see us. The answer you're looking for, yours, is not so, straightforward because there's so many different devices, so many different things that could be occurring here, and it's just challenging to answer this in a straightforward way. But I think it resolves itself in that, one, we have to be confident in what we're doing and that we're setting a path for the patient to have success, but also that they know this is a process that they have to come back to and give feedback so that we can know what additional steps or changes may be necessary to make.
And how about as you guys, if you look at this market from a CFAB point of view, is that whole 3D scanning,
sure,
3D printing thing, is that the Valhalla for you guys, or is it no, it's not really a big deal?
Yeah, we're definitely working towards it and currently accepting scans for AFOs. A lot of people are asking me to accept scans for KFOs too, and we're working towards that, but we're trying to really make sure we have validation on cast alignment and corrections in what we're doing. I think it all starts with proper input, right? So we need good inputs to make quality fitting devices. We say it all the time in this field: garbage in, garbage out, sort of thing. But we have to be critical. Am I providing good inputs so that they can then come out with the device that I want as well too? I recently was speaking with some colleagues in the UK, and they told me that if a cast was sent to them and required cast correction, they'll send it back to the clinician. So, I love that. I love that the standard that holds the clinician to, as well as the lab too, that integrity of saying, well, we can't really build something and assume that because we wedged a cast in a few degrees this direction or that direction, we can necessarily move forward and confidently fit a device then that this brace is going to fit well to. you should see some of the molds we receive here and what we're being asked to position them at compared to what they come in at. I've recently reviewed like what I received at Northwestern, which was take the mold in the position that you're anticipating fabricating the device in. I've reviewed the old Oregon orthotic systems casting stuff, and what they gave customers was up to a 5-stage KAFO casting process. And the end statement of that casting course is you need to provide us with a mold that is representative of the shape of the device that you're anticipating fabricating. And I think that, how we contain tissue and hold tissue, we think about a lot in prosthetic shape capturing. But orthotists need to be just as concerned about that when they're looking at the thigh or they're casting a patient supine, and make sure you bolster underneath their glutes so that their thigh isn't flattening out. Or do a 2-part cast where you get semi-weight bearing below the knee and then let that completely harden, then have the person lay back, extend the knee, work on that next. You have to think about your process significantly whenever you're doing anything in this field, because if you don't, it's going to have an impact on the output. And with scanning, I could tell you that the better quality scans we receive from some of the better scanners, you're going to have a better outcome. And the difference on the scans when they arrive to us. We have better results from people who are positioning their patients using, clear plastic boards. They've thought about their scanning setup, lighting in the room. All of those things matter towards that scanning outcome. Or scanning the mold, they actually fill the positive mold. I think you get a much better quality fit than if you're scanning the outside of your mold. It's just that's going to have an impact on the input has an the input has a impact on the output no matter what we do, and we have to be concerned about the quality of the inputs we're providing, and especially when you're working with the CFAB, because they don't have the advantage of having seen that patient and knowing what you know about that individual.
Yeah, I think it's a good point of the scanners. I remember in Holland at one point, the government had this really well-meaning initiative where you could get like an innovation credit, and it was like $2,000. I don't remember exactly what it was, but it was like $2,000, something like this, which meant that a whole bunch of people started buying $2,000 scanners. And at the time, this is years ago, there weren't that many good scanners out there for $2,000. So what you had is all these people that had these really bad products making really bad scans, right? And then they would have to learn CAD to patch it all up, and then that was also not sufficient. So, do you have an idea of like what kind of scanner you would need to use, or some of the qualities that scanner would need to have, or some of the qualities that set up? I think that the clear plastic board, the kind of fitting board, and all that kind of stuff. That could be a good idea. Do you have any kind of more recommendations how to scan properly, let's say?
Yeah, I think you need to really be concerned about your setup and know that those things have an impact. The clear plastic boards that are out there are great for semi-weight bearing. If you're not doing that, then you need to have a plan for someone who's holding the foot while you're scanning, if you're direct scanning a patient. I also really think it matters what the device is that you're scanning too, right? Like the cranium in some ways is easier because it doesn't have the moving parts and such that the other parts of the body do. It's more of a fixed shape. But when we were in the hospital, for example, there was a quality difference between if I was scanning in my patient room versus when I had to go to the OR and scan a post-operative baby for a helmet. It was more challenging, and I had to be able to go into that OR and say, I want these lights turned this particular way, and I need the child positioned this particular way, and really run the OR and be confident enough to tell the anesthesiologist and the other people in the room, because that affected my outcome as a clinician. When we were doing spinal jackets in the hospital, we could get a CT scan from the ER within a 24-hour period. and we'd get a kind of surface level scan, but it wasn't in a position where it had, the right lordosis for what we needed. It sometimes was muddled a little because of the clothing or other things they had on. But we could use that along with our measurements and then CAD get to a model shape that was relatively, close to the patient. And there's a lot of forgiveness in that type of device. When it comes to an AFO, there's a lot less forgiveness, especially when we're trying to control posture. So you have to be that much more concerned about the quality of that scan. And it's hard too, because some of the scanning software doesn't give you all the feedback you need as a clinician when you take the scan. So, for example, we've had clinicians on the order form, right? Well, I want a 16-inch AFO fabricated for us. And then they send you the scan. The scan looks good, but it's only 13 inches tall. Well, I'll just make up the other 3 inches and what happens up there. So it's like if you need to know and verify your scan, I think that's a good step for clinicians to know what they're sending out, that it is actually one-to-one with what their measurements were. So I think that works well. I know the feedback from clinicians who send us already modified scans are real happy with the fits. We're happy to take an already modified STL and fabricate you an orthosis. So those are things that, again, I think you really need to have a understanding of what is the CFAB doing with the input that I'm giving them, and what are the challenges of the input that I'm giving them or not giving them. So I do think there are really good scanners now on the market, relatively inexpensive, that have a fixed cost, that once you use that scanner, you can get, you can keep the STL, like the Einstar scanner is a good one out there. And, that opportunity for clinicians to buy something that high quality for $1,000 when before it was $10,000 or $30,000. I think the first scanner that I ever encountered in the field was $30,000. And I just think, we've come a long way in what we can put in someone's hand. But I also think a word of caution on some of the other scanners that are, fit in our pockets on our cell phone is just the differences on technique that needs to happen. I recently switched from an iPhone 12 to an iPhone 15 and discovered you have to be even much closer to your patient or your model as you're scanning with the new iPhone because of the change in the hardware technology. So it's really interesting to me see how that stuff evolves over time. I'm glad people are working on it and making it more accessible to us as a field. But I think you need to be critical of what you're doing and how you're doing it, and whether you should be doing it or not.
Okay, that's super cool. And then with the, and I think it's really important that you say this correct dimensions. This happens a lot in ADA generally. Do you also think, like, I know that certain people making like customized insoles and things like that, they have footbed scanners as well, and other kind of like equipment for measuring tread and then all that kind of stuff. Do you see any movement in making that more available for orthotics offices and stuff like that? These tools becoming cheaper because, like you said, scanners, they've gone on a really, really considerable journey. But this other equipment seems to be quite rare and quite pricey still, right?
Yeah, I think that's going to be the tipping point for more adoption, right? And that's always the case of newer technologies too. But as it becomes more reliable, more accessible, then there'll be further adoption into our field. Of course, I think, I'm really interested and have been interested to engage in these things and these conversations. That's kind of how I started talking with Brent the first time, and still would like to do more. And as a clinician, there are certain things like, there isn't something available to this patient that's off the shelf or even easily customizable solution. But if I could 3D print it, then it would be amazing. One encounter I can distinctly remember is like a 8-month-old child that needed a CTLSO because of a fracture in the C5 vertebrae, right? And in being in a hospital, I have access to this CT scan and can get a beautiful 3D shape of this person without even having to do the trauma of rolling them or measuring them. And that would have been a perfect application for these kind of things. But then having the access to the machine that can print that and the engagement with the person to do it in a fast way is the ideal. That's the future. I think that hopefully someday hospitals have that relationship with and that ability to do. But right now, I think it's still not there. And there are certain places, certainly around the country, where that's more the case. I think the relationship with the radiology department in those situations is really important. I saw the advantage of that, but there still could be more to move people out of their silos and work together and collaborate to get some amazing patient results and new solutions in areas where we're not necessarily addressing or delivering devices to currently. I think there's opportunity for us. So, but yeah, I think there's movement in this direction. I think we need to be concerned about the outcome of the devices that we're providing to customers, to patients, and I think that's why, just because we can build something a certain way doesn't mean we should. I think we need to think about, are we getting the outcome from making it this way too that the patient needs? So I'm still a believer that you do need to incorporate componentry into your designs more. Again, I became a big fan of this one particular joint because it for me is a big shift in how I can treat a patient kinematically and gain a better result, to the point where maybe someday they no longer need to wear an orthosis as well. And I've seen those results clinically that I feel like we need to have that message more as a field too. I recently had a conversation with a PT who had done a neuro training out at Rancho in California. And she said she'd seen one of my talks and she'd been like, well, yeah, when I went out to Rancho, I saw those metal ankle joints all the time. And they would fit patients in inpatient rehab with those. And by the time they got to outpatient, they no longer even needed AFOs. They were doing so well. And I think that's an important message for our field too. Like, if you don't overly block plantar flexion, you actually can address a patient's kinematic really well and get a good result for them. They may recover that they might not need our services any longer, which to me should be part of our goal and what we're doing. So we have to understand there's consequences when we're making AFOs that overly restrict plantar flexion or prevent proper biomechanics. And that may be keeping your patient from making the progress that would eventually help them to no longer need that service too. And of course, that's very clinical rhetoric and not necessarily well researched, but it's something I see happening in our field and in our world that I think we need researchers to look at more critically. We need to understand, why are we having those outcomes in some cases, but not in other cases? And that's why we do things, 100 different ways to treat the same patient presentation too. So sorry, I went on a crazy tangent there. But
No worries. No.
Well, I think that's good because, and I want you to dive a little bit deeper into this idea of allowing plantar flexion and dorsiflexion. And you mentioned a little bit earlier that about the triple action joint and what gets you so excited about that. So can you, in a cliff note, but don't hesitate to get into the weeds a little bit, just share with our audience why you feel so strongly about that. And
I think even clinicians who have adopted the use of it still don't have a great understanding of, for the most part. And frankly, I didn't really until I began working here and started teaching about it. But the unique part is that we've developed this systematic approach on how to adjust the joint. And, it came from some biomechanical research that led to that. We start by taking away all the dynamics from the joint. And we begin with static alignment, just like you do in prosthetics. You set up the TK alignment, you set up your shank to vertical alignment, and you have to have good postural control. Once you've accomplished that, then you start. The goal for us is to have the least restrictive orthosis possible. So we allow for more and more freedom of the motion of the ankle joint, first into plantar flexion and then into dorsiflexion. But while you're doing that, you're paying attention to specific gait events and maintaining good quality. And I say this is our opportunity to work a little bit like optometrists as you make it less and more free, less and less restrictive. What you're judging is that gait still as good or is it better? And you get to a point where, again, the gait becomes bad. We got to remember our patients have abnormal gait, then they're moving in ways we do not want them to move. So we have to restrict them in particular ways. And we do that with these springs, and these springs are much stronger and more durable and all that. I could go on for hours talking about that. But what I am excited about is that ability to see the progress in the gait and to really optimize it for the individual. And then you can also make their gait bad and say, okay, I went too far. I gave you too much freedom. So let's go here. And the exciting part is what you see those patients doing in a month or 6 months from now, and the changes you can make and even be less restrictive. So, for me, as probably therapeutically minded from my athletic training days and just working with the neurotherapists that I have, my goal is always to be the least restrictive in orthotic design possible. And sometimes we compromise, and sometimes we're overly restrictive because we need that for protection of the joints. But to be able to dial in the kinematics of the knee and the hip from all at the ankle joint is really exciting to me. And a lot of orthotic designs, I call it our ski boot walking problem, because I love sitting in a ski chalet and I like watching people walk down a ramp in ski boots, right? It over accelerates your knees, it over accelerates your hips. And if you watch closely on a lot of your orthotic designs, we've been doing that for far too long. And, we all went to school and we were told you fit a solid ankle on somebody, you have to do shoe modifications with that. Well, how many people do that in the real world? And, you fit a rigid plantar flexion stop, you should have a satch heel in the back. We don't do that. And that has a cost and an effect on your patient's outcome and ultimately how tight they are at their knee, how long their stride length, how much energy they're using during gait. So it's great that we can make all of these fantastic things. I still think we need to be concerned about the componentry we're putting in and ultimately the result we're having for the person with their gait, because that is what we are doing as clinicians, is trying to improve their gait to the best quality and outcome that we can.
Okay. Super cool. Super cool. And how about like using 3D printing for the final devices? Are you excited about that?
Yeah.
Is that limited? What do you think about that?
I think there's real challenges, and that's something, I'm working on a little bit on the side, or a back burner project, and Brent's engaged in this a little with me too. But part of the challenge is we have to bend the metal sometimes to the patient model before we can build those shells. There are certainly ways to integrate them externally too, but from an intimacy and fit way, that's one way I think we can do it. There's other solutions, I'm sure, that are still coming that are out there too. But bending the metal and then building the shells around it, I think, is certainly one approach to getting there. And I think there's a possibility that there's a way to incorporate more of those materials and opportunities for us as a field to engage in that. So definitely working on that, seeing it as a way we need to evolve. We need to figure out, there's a reason components like this are still really needed. I also think, everyone talks about like, oh, this is going to be the next thing that disrupts the field or takes over all this, and I've watched how, since I've been here at Becker, the growth of our metal and leather department, because no one else is doing it anymore. But also, it didn't disappear. The video didn't kill the radio star. We all have radios that we listen to, or maybe you don't, but I turn on the radio every once in a while. It doesn't go away. It's just another tool in the toolbox. And I think we need that as clinicians. We need more approaches, more diversity to what we're doing and understanding, but we can't be shut off to maybe for a certain patient, I gotta build a conventional AFO because of their fluctuating edema and their weight and the other reasons I might need to do that too. So that's again the challenges of being a CPO or a clinician in our field is just the breadth of knowledge and the consideration that you have to have with every patient encounter on what all the solutions or options might be for that individual.
All right. That's a very, really good end statement there, Sean. A really, really great one to end on. Thank you so much for being with us today.
No, I appreciate you guys. Just the conversation you create for all of us. I do enjoy listening to the podcast and hearing what other people's viewpoints are and considerations are. And it's great that we get to engage in this way. And thank you guys for hosting that and inviting me today.
Awesome. No problem. No problem. Hey, and Brent, thank you for being here today. I think you enjoyed this too, right?
This was good. I mean, Joris, at times I think I saw your eyes glaze over when we started hopping into the weeds a little bit, but you hung in there really nice. So, but I think that there's going to be a lot of people that appreciate this episode, especially diving into the weeds of some of the alignment and just the what ifs and can we do. And that's why I really enjoyed having Sean on the podcast. So thank you.
So thank you so much for our sponsor, Advanced 3D, today for making this all possible. And, if you need any custom fabrication, custom design for additive manufacturing, 3D printing work done, or you want to, delve deep in the engineering side of your next 3D printing project, head out to Advanced 3D. And I'd like to thank very much as well the most important thing to us, of course, our listeners. So thank you for being here with us today. Thank you.